Okay? So let's look at our next problem. We have a grocery store problem. Now we're moving more into unit rate. So we just did proportions. We can use proportions to help us with unit rate, but in this case, I don't think we're going to need to. At Hometown Foods, Pop-Tarts are 4 boxes for $11. At Landry's Groceries, Pop-Tarts are 6 boxes for $16.50. Who has the best deal? Classic problem. You run into this weekly. Some of you go shopping more than that and buying up those tasty Pop-Tarts. That was just the bell ringing. Don't mind that. So let's find out what's the best deal. We never want to get ripped off. We always want to get the best bargain. So when we are looking at unit rates, I always like to pull out the 2 variables. My 2 variables are boxes and dollars. Boxes, dollars. So when I set up my unit rate, I know that I can have 2 different situations here. I can have boxes per dollar. So I could walk into my grocery store with $1 and say, how many boxes can I get for $1? Well, they're going to tell you, none. Well, can I just pull out a package of Pop-Tarts and buy that? No, they're not going to let you do that. Boxes per dollar or dollars per box. And this second one is probably the one we tend to think of the most. They're both right. They both have value, but one we would tend to use more often than the other. Just like in the last problem with the F-150, miles per gallon is the most common way to say it. Or you could figure out the gallons per mile. How many gallons do you burn every 1 mile? It's going to be a very small number. So we don't like to think of that. We don't like to think in terms of decimals. So we're going to do miles per gallon. Just like over here, we want to do how many dollars is this 1 box going to cost me? So since it's dollars per box, this per symbol right here in the middle means division. Okay, that slash means division. So I'm going to do Hometown Foods. I'll just abbreviate it HF on one side, and then I'll do LG over here for Landry's. Okay, so Hometown Foods, I want boxes per, dollars per box. Said that backwards. So I want dollars divided by boxes. And I'll distinguish this. This is just an underline here, not a division sign. I don't want that to be mistaken. So dollars over boxes. Well, how many dollars do I have? It's going to cost me 11 for 4. What's my unit rate? All right, well, we'll use my handy-dandy Smartboard calculator. So it's literally just 11 divided by 4. So it's $2.75 per box. And I'll move that down here. So $2.75 per box. Okay, Landry's. Let's do Landry's now. Landry's Groceries are selling 6 boxes for $16.50, so $16.50. Since I want dollars on top, dollars per box over 6 boxes. All right, we'll use our Smartboard calculator again. So my problem says $16.50 divided by 6 boxes equals $2.75. Per box. Interesting. They're the same. So who's got the best deal? I would say whatever store is closer to your house, where you have to drive less, go to that one. So they're the same. You can break it down per 1 box. They're both $2.75 a box. Go either place. All right. Let's move on to the next problem. This biplane can cover 5,000 feet in 25 seconds. This jet engine truck covers 1,827.5 feet in 8.5 seconds. I actually saw this happen one time. A biplane going full speed raced a jet truck. The jet truck won. It was pretty cool. Cleveland Air Show, they come up with some pretty crazy stuff. So the biplane, we need to know how fast can this biplane go? Or who's the fastest one? So again, let's identify our two variables. We have feet and seconds, or feet and seconds. So I know that I can have two different unit rates. I can have feet per second or seconds per every 1 foot. Well, you're already sitting there thinking, I've never heard of people talking seconds per foot before. So I think, and that's going to be a very, very small number. How many seconds does it take to cover 1 foot for a jet engine truck? Well, 1 foot for a jet engine truck is nothing. So that's going to be a very small number. So let's not worry about that. Let's go to feet per second. How many feet every 1 second do these two modes of transportation cover? So since I know I want feet per second, that tells me what I need to do. So I'm going to put feet over seconds. So feet over seconds. And it's 5,000 feet for the plane over 25 seconds. And then we'll come down here, and that will equal some feet per second number, and we'll come up with that. And then the jet engine truck, 1,827.5 feet every 8.5 seconds. All right. Well, let's get the calculator out again. 5,000 divided by 25 equals 200 feet per second. Okay? So the biplane covers 200 feet every 1 second that goes by. Well, how about the jet engine truck? 827.5. Oop. 1827.5 divided by 8.5 equals 215. Okay. 215 feet per second. Well, I can see that the jet engine truck is just a little bit faster. It's covering 15 more feet every 1 second. So it's going to just start to get further and further away from the biplane. So the biggest things that I want you to remember from this is, first of all, label correctly, whether you're doing a proportion or a unit rate. Label correctly and consistently. And then on top of that, just remember, if you want feet per second or second per feet, it's the order in which you divide. Just like the proportion song, the order in which you divide determines your thinking. So am I thinking in terms of feet per second or second per feet? Well, since we divided feet by seconds, we're thinking in terms of feet per second for that unit rate. All right, hopefully this is helpful. Thank you again for checking in on these videos. Look for the rest of them. Happy mathing.